Okay, so I think we can start our class for this morning, but many are entering still. Right, so for today, we will move on with the next part of the network diagram. Okay, so we have done basically the fundamentals of the network diagram. How do we calculate the forward, backward paths that actually provide us with the critical path in a project. Okay, and the next part of it is basically the crashing. Okay, so crashing in a sense that we crash the duration. So we are trying to find the time cost optimization. So we are trying to conduct time cost optimization to find the most optimum duration where the cheapest cost occurs. Okay, so that's the idea. Let me just play on the slide. Okay, can you guys see the slide? Hold on, Okay, so the next part of your there are some I think the front part of the lecture I took it from the notes in my folder, but the example I kind of like took it, but I kind of tweak it because the example given in the notes are basically using CPM, activity on arrow. So I wanted to change the example to activity on not. Okay, so hence there are slight difference, but I will upload this note. I will provide in the group as well as the upload it in the folder in your future so that you have the latest slide. But the front part of it is the same, except that the back part, if I'm not mistaken, in the folder, in the you future folder, it is using activity on arrow, which is the CPM method. Okay, but we will be using activity on not or precedence diagram method basically to conduct the time cost optimization. So that's why I require you to come up with the paper and pen so that we can go through these steps. Okay, so we have quite a few steps. So I need you to do it one by one. Okay, so we'll do everything as per the progress, as per the process. Okay, so right. So let's just move on with time cost optimization. Right, so at the end of this, you will be able to understand the technique to obtain the most optimum duration at the lowest cost. Okay, why? Because sometimes when we come up with the first duration, okay, so let's say we come up with the basic schedule or the first preliminary schedule, the client might not be happy with it. Okay, so the client might be requesting you to reduce the duration or increase the duration, depends given the circumstances what the client requires. So hence, if you are trying to provide a decision or if you're trying to suggest client a certain decision whether to reduce the duration or increase the duration, there should be consequences to it. Okay, so the consequences is usually related back to the cost. So how can we give that to the client so that the client makes an informed decision is through this time cost optimization. Because sometimes we may provide the duration, one duration, for example, as the one we have provided before this, done before this. But how can we be sure? Okay, so and maybe there are cheaper options to the ones to the one duration that we have proposed. Okay, so basically time cost optimization. Okay, so it's studied to consider the options available in balancing out the time saving against the cost of speeding up. Okay, so the idea is to find the time with the cheapest cost. Okay, so that is the idea of this time cost optimization or crashing. So we are trying to crash the duration to see that or to identify the cheapest cost your duration would occur. Okay, so client contractor could assess the effect on direct and indirect costs of reducing the overall project duration. Okay, so project period. So the important terms that we are talking about here is direct costs, we have indirect costs, we have total project costs, we have optimum project duration. Okay, but just as a brief description, direct cost is anything that directly affects your productivity. Okay, so when you're talking about direct costs, so when we are talking about direct costs, okay, so anything that directly affects production. Okay, so any cost that affects your direct production. So which means without this cost input, your production would be affected. Okay, so which means your productivity at site. So how much can you complete in a day? So your direct cost would very much related to the human. Okay, so the workers. So if you reduce the workers, you will reduce people, or you will reduce the human resource directly building up the construction or building up the project. Okay, and other direct costs are such as machinery. Okay, so material, so those are directly involved with the production on site. Okay, so on-site production. So basically, it relates to productivity. Okay, indirect costs are costs that supports your production. Okay, so not necessarily that you add indirect costs, you will increase the productivity. No. Okay, so your indirect cost is just the supporting cost. So indirect cost is basically supporting cost. Okay, so for example, if you are trying to increase engineers on site, okay, currently you have 2 engineers, and do you think adding in 3, 4, 5 engineers will increase the production rate? Tak. Okay, so they are not directly building the construction. Okay, so those are basically indirect costs. For example, site cabin. Okay, so the cost that is involved in building up or maintaining a site cabin, workers' quarters. So unless you are introducing more workers, then yes. So workers are direct costs. Indirect costs are just supporting costs. That does not necessarily mean that you increase the indirect cost, you will increase production. Okay, so it's just supporting. And total project cost would be the total of direct costs and also indirect costs. Okay, so because you need both costs to run a project, you need all those workers on site, you need the machinery, you need the material, and at the same time you need engineers to direct, you need site supervisors, you need site clerk to make sure your documentation on site is in proper manner. Okay, so those are supporting and direct, but you need both to ensure that you have the total project cost. Okay, and your optimum project duration occurs when your total project cost is the lowest. Okay, so lowest total project cost would give you the most optimum duration, but it can be longer than what the client wants. So hence, any proposed duration with the cost and so on, it should be related back to the client, whether do they agree with that or not. So it goes back to priority matrix dulu. Okay, so is the cost factor or is the time factor on constraint or to be enhanced? So it relates back to what the client wants. So we might provide, or we might give this option that okay, the cheapest cost occurs at such duration, but it depends ultimately on the client to make the decision. Okay, so these are a couple of important terms you need to know in terms of time cost optimization. Okay, so as I've mentioned, direct costs basically involve the labor. Okay, so involve plant, any equipment. Okay, so the number of trucks, especially if we are talking about site clearance, for example. The less excavator you have on site, the less truck you have on site to move around the soil. Okay, so it will take a longer time for site clearance lah. Okay, for example, something as such. So the more trucks you have, the more excavator, the more compactor you have, you should be able to complete your site clearance much earlier. Okay, so that is a clear example. And then materials or any operating cost on site. Okay, so those are basically type of direct costs. And basically when we are talking about direct costs, okay, so activity accelerated, your direct cost will increase. Okay, so non-linear with time. Okay, so you have the cost, you have the duration. Okay, so activity accelerated. Okay, so accelerated meaning to say that your duration decreases, your cost will increase. The shorter your duration, the higher your direct cost would be. Okay, so direct cost. Why? Because you are pumping in all the equipment, material, machinery, labors, a lot. You know, so because when you're trying to shorten duration, you need to have that a lot. So in order to have that, your direct cost will increase. So anyhow, whenever you have this direct cost, it is non-linear with your time. Okay, so reason is where you need more workers, more materials, and so on. So when you're trying to finish up your work fast, your direct cost will increase, because this is the basically short-term approach usually. Okay, so whenever you come across any delay or whatsoever, usually we will work overtime, we will pump in, get in labors, a lot of labors to ensure that we get back on time. Okay, so that acceleration would increase your direct costs. On the other hand, we have indirect costs. Okay, so time related costs where it changes as the project duration changes. Okay, so for indirect costs, so your time and cost are basically constant. Okay, so as such, so you have your indirect costs and your duration. Okay, so the longer your project, the higher your indirect cost would be. Okay, why? Your salary, the salary for the engineers, the salary for the site clerk, the salary for site supervisor, as well as the rental of the cabin, utility bill is more or less constant every month. Okay, so the shorter you are on site, or the shorter your project, you can complete faster, your indirect cost will be lower. But the longer you are on site, your indirect costs will increase constantly, because you are paying them every month at a constant rate. Okay, so cost and time are basically constant. So your indirect costs would include project supervision. Okay, so site engineers, site supervisor, and all the other on the supervisory team. Site accommodation. Okay, so all the utility bills, workers quarters, if the cabin are under rental, so usually is in a month rental. Temporary services for site office. Okay, so these are the utility bills, or any site transportation. Okay, so if you need to transport your workers from outside, so maybe there are site transportation related, as long as you are on the site and as long as your project is ongoing. So to reduce indirect costs with a proper balance of the workers required or the site personnel required, so the way is basically to shorten the duration. Okay, so all the salaries of the engineers and so on. So because no point that if you are delayed, you add on the engineer. So it does not serve function on the site itself. Okay, so that's the idea. So when project accelerated, indirect costs will decrease. Okay, so as such. So if you accelerate, if you reduce the duration, you would reduce the indirect costs. Okay. And reason is being that contractor will be on site for the shorter period, so hence there will be reduction in the site administration costs. Okay, so what will happen when a project is to be shortened? Okay, so sometimes it comes to a point where we need to shorten a project. Okay, so usually the short term measure that we carry out when a project is to be shortened is work overtime. So this is quite common if you have known in construction. Sometimes when we are in a acceleration mode, when we are trying to reduce a project duration, the work is to be done overtime. Okay, so it could be more than the time period that is common, or you need to work following shift. There are morning shift, there are night shift to a project, especially if your project is a critical, or I wouldn't say controversial, but a project that is under um, scrutiny of the media, for example. Okay, or is that is seen in the eye of the public. So those are projects which needs to be shortened the duration. Then there are measures we take. So these are basically short-term measures. Okay, so these are basically just to get the project back on time and also to ensure we complete on time. Okay, so over time, um, following shift. Okay, so by doing that, basically you need to add on the equipment, the machinery, so which will increase the cost of mobilization and also demobilization. Okay, so when a project is to be shortened. And when do we need to shorten the duration? There are several circumstances that we might come across. Okay, so over purchasing of material. This one would happen sometimes. Okay, for example, we have over purchased materials which could due quick, okay, or which would get spoiled if we leave on for a longer period of time on site without proper storage, without proper storage area. Okay, so for example, site reinforcement bar, for example. Okay, so if you have over purchased all this rebar and you do not have a proper storage area, and due to the rain and what's not, okay, so it would get corroded. Okay, so sometimes when it get corroded is leceh, because when you're trying to install especially rebar yang crucial for foundation, for example, you need to brush off the corrosion and so on. Okay, so and it could reduce the dimension of the original rebar tu. Okay, so sometimes there are elements or sometimes materials which might get spoiled over the exposure to upper weather condition. Okay, so something as such. So over purchasing of material and without any proper storage, then you might want to use it fast habis cepat. Okay, this one is a common factor, political pressure. So there are projects, especially mega projects, which are under public scrutiny. Okay, so where we need the project to complete as promised or as planned. So with that, obviously, you would see projects which as such there are night shifts and so on. So you could see certain projects that actually being being constructed during night time and so on. So due to the time frame that is being given, and if there are delay, you need to shorten to ensure that your project back on track too. Okay, other than that, why else do we need to shorten the project duration? It can be because weather condition. For us particularly, if we are trying to proceed with our construction before the monsoon season, for us. Okay, so Hold on, monsoon and the four season countries. Okay, so for us, basically a lot to do with the monsoon season, especially starts the end of the year. Okay, so monsoon Timur Laut tu. So November to March, more or less, you can expect rain continuously. So if you're trying to create or if you're trying to do site clearance at that point of time, it will be critical, okay, especially on the Pantai Timur, basically. Okay, so such site clearance during monsoon, which you have rain from morning to evening, so it's pretty much crucial. So for site clearance on such area, okay, on such state, you might want to do it much more earlier. So if your project starts in August, most probably you still have time to actually complete your site clearance much earlier. So hence, you can actually start up on the building itself. Okay, so if you have already done the foundation and the slab starting, then it is not too bad. Okay, so for you to actually have your construction still ongoing, but at least reduce on all those pollution that you might cause. Okay, so weather condition on earth, it is a lot to actually reduce the site clearance or earthwork during the monsoon season. So same goes to countries with four season. So usually countries with four season, they have this time frame where it is non-earthwork season and also earthwork season. So non-earthwork season are basically during the almost fall, winter kind of season, more or less winter lah. So prior to winter sikit. So non-earthwork season and earthwork season are basically during the summer. So and there are time frame for it, and of course when you're talking about four season, they have time shorter daylight. So such as during winter, basically your daylight starts at 8 and by 4 it gets dark. Okay, so with that short daylight, it's quite difficult for you to conduct your construction as usual. Okay, so hence usually people will refrain from having their construction during the non-earthwork season too. So in order for you to do that, you need to kind of compress your production during the summer season. Okay, so weather condition affects a lot, but for us, not much on the four season. It goes back to the monsoon. Okay, so we will try to refrain. If your project starts in November, probably you will need to delay. But if your project starts in August, you might want to shorten up your site clearance. You might want to expedite before you actually go into the monsoon and you can start on the building itself. Okay, other reasons that we might need to shorten the duration, basically having other project in hand. So this one, it relates with contractors who are having several projects in hand. Okay, so probably they have one which is already 80%, one more which is starting 0%. So of course they want to complete the one in hand cepat so that they can move on to the next project. Okay, so for any question on this?
No.
All right, so next, what will happen when a project is to be lengthened? So because when we are talking about time cost optimization, there are circumstances where you might reduce the project, shorten the project, or you might also lengthen the project. Okay, so there are two ways of looking at the duration. So it depends on what the client wants and what is the optimized duration for the project. So what will happen when a project is to be lengthened? Okay, so when you lengthen a project and when you are trying to extend the time frame of the project, usually your material is not bought in a bulk. Okay, so your material will be brought in bit by bit. So when you bring in bit by bit, it will increase the transportation cost, the material cost, because of course when you buy in bulk, it's basically cheaper. And of course, if you're talking about nowadays SDG and so on, bringing in bit by bit would increase the pollution. Okay, so would increase the emission to the air basically. So because you have trucks coming in bit by bit. Okay, so those are the circumstances if you are trying to lengthen the project, because you don't want to have too much material on site which might get spoiled with exposure and so on. Okay, and of course when you're lengthening a project, okay, so you have less worker, less productivity, affect the morale. Usually you can see that towards your project would be the most active when they have structure work, architectural work, and many work running in parallel with each other. Okay, so you can see you know, it is a very active project. But towards the end, okay, so towards where you have completed all the structure works, you are left with a little bit of painting work here and there, a little bit of plumbing. Somehow rather it gets kind of slower to complete a project. Okay, so that could be affected by the less productivity on site as well. Okay, so less morale and so on. Okay, so when do we need to lengthen the project duration? Okay, so what are the circumstances that cause us to lengthen a project duration? Well, one, if you have shortage of resources, okay, in the midst of progression. So for example, if you require certain material which are short in supply, then we can't do much. Okay, especially if you try to sort to other suppliers, but yet you cannot get such material, you might need to lengthen the duration. Okay, especially if you're talking about material which do not have much supply, or material that has been imported but you still short on the material. So those are the reason that you might want to lengthen the project duration, because you don't have the material required in hand, unless you can substitute it, unless the client allows the substitution of the material. Okay, um, for example, okay, so if you're talking about spanpal, so probably there are not many or suppliers on spanpal. Maybe now there are more, but let's say those days, so the spanpal might not be that, how to say, that much supplied by supplier. Okay, but there are other ways. Rather than using a spanpal, you may use just a square pal. Okay, it's just that spanpal is much more solid. Okay, so and the way of actually processing the pal cap, because both of it at the end of the day, when you're trying to come up with this foundation, pal foundation, so you need to have a pal cap. So before you can come up with a pal cap, so the way of processing is slightly different. Okay, so for spanpal, do you know what is a spanpal?
No.
Sekejap let me see if I can find. Okay, this is a spanpal. Can you see?
Yes.
Okay, so this is a spanpal. So basically spanpal macam ni. So it is a pre-stressed pal. Okay, so it is much stronger, and basically when we are trying to build a pal cap based on spanpal, kita potong dia. Okay, so we slice it to the level that we want. Okay, so that is spanpal. Square pal is as such. Square pal. So square pal is not pre-stressed. It is just concreted. You lay reinforcement bar. Okay, so square pile is as such. Okay, so it is just a normal concrete pile. Okay, so the reinforcement within it, it is not pre-stressed. So when you are trying to come up with a cap, Okay, so when we are trying to come up with a pile cap, so this is a pile cap. Okay, so you have driven in the pile. Okay, whether it is a span pile or square pile, you need to have this reinforcement bar coming up here. Okay, so that you can build a pile cap. So this is a pile cap. So this is a pile cap, for example. Okay, so pile cap. So you have several piles building up to a pile cap, and from the pile cap yang you can start having this column on top of it. Okay, so your whole column rests on the pile cap, and your pile cap delivers the force to the bedrock through the pile. Okay, cuma beza dia if you are trying to use span pile, for example, so span pile. Okay, so the way we actually build a pile cap, because you have pile from the ground. Okay, so usually to build it, you need to cut the pile cutting lah, cut the pile. So usually it's much easier to cut span pile because basically you just cut it. Okay, so to the level that you require. So and then once there, usually you have something as such. So this small thing to stuff it in the center, and you basically complete it. So this one will connect to your column nanti, to your pile cap tu. Okay, square pile pula, because it is as such and your reinforcement bar, it is not pre-stressed, so you need to hack it. So you need to break it up, and then you pull it off. Okay, so you will have this reinforcement bar remaining. So this one you hack it. Okay, so you just slice cross it, is very much easier, and you place this here. Okay, so that it will be connected to your top column or to your pile cap kemudian at the top. Square pile, you need to hack the concrete part of it. Okay, and then from the top you need the crane, or you need the yeah, basically crane lah. Okay, so to just pull it off, and then you will remain this reinforcement bar here. Okay, cuma di in terms of two different piles ni, span pile is much more stronger lah, it's pre-stressed. So square pile would have a lot of damages. So sometimes during the driving of the pile, it will break easily at the top, and it will, and basically sometimes your pile is not driven straight, then it will just break. Okay, so it's slightly, or it is very much differ in terms of the strength. Okay, so hence square pile leceh. So sometimes at one point, okay, so normally you'll be given this plan, piling plan. Okay, so it is required for you have pile here, pile here, pile here, pile here. Okay, so usually for a span pile, probably you can get it right. Even if you connect 2-3 piles together, you can get the point as nice. Cuma sometimes square pile, okay, so we try to drive here, but let's say if it's broken at the top, you can't connect 2 piles together. So hence you need to create another point nearby. And sometimes you can create 2 points nearby. Mungkin this is broken, cannot use. This will be 2. So it will disturb the original pile plan lah, initial pile plan. Okay. So why I'm mentioning this? Span pile is not much in the market. Okay, so square pile, because it does not require that much of a high technology factory. Okay, so it is just a pile, not pre-stressed, concreted, so it's very much easier to manufacture. So span pile is much more difficult, and basically it requires higher capital. So hence you can have this shortage of resources if you are using span pile. But alternatively, if you can get the green light from the consultant, then you can substitute with a square pile. But let's say if a certain area, is crucial, and it really requires the strength really should be placed on a span pile because it's a pre-stressed pile, then you would have problem, shortage of resources depending. Okay, so usually on construction site, we try to see what are the other alternative that we can use, and we propose to the consultant. So if the consultant could agree with substituting square pile, then it shouldn't be a problem. But if you can't, then it will create a problem here. So then you might need to lengthen the duration and so on. Okay. Other than that, important factor that when we are talking about lengthening, sometimes in terms of cash flow. Okay, so we do not have, or especially the client do not have a proper or positive cash flow. Okay, so progress payment are not being paid, or if it is being paid, it is delayed, and we have contractors who might not have the sufficient capital to top up. So those are the issue. Okay, so negative cash flow, and sometimes planning too fast. Okay, so this one goes back for the project planner, especially for example, you came up with the network diagram. Okay, so you came up with the duration, you came up with the estimation, but your estimation of the duration, does not properly being reflected by the resources you have in hand. Because sometimes planner is, or the schedule planner is someone who is based at headquarters. Okay, and the people who is doing the job is actually the someone on site, but both of them do not have this correspondence between them in coming up with a plan, because the site personnel might not be the person who is actually doing the plan, who is coming up with the schedule. So it's like chicken and egg lah. Okay, so basically very important when you are the planner, when you are actually drafting the schedule, the input should come from the site production. You need to know what is the most reliable or closest to correct estimation of the duration. Assumption would not do it. Okay, so when you assume and it does not reflect the resources you have in hand, it is sometimes planning too fast. So your duration, let's say based on the resources you have, would take 1 week. Tapi just because you don't know how much resource you have in hand, you assume benda tu lah, it can happen. This one will be human error. Okay, so when you plan too fast, it goes back to the error of the the planner. So because you did not have a very informed information on what is the most potential or possible duration. Okay. All right, so total project cost would be the summation of direct cost and indirect cost. Okay, so when you put it in a graph form, so usually your indirect cost will be the lowest. Okay, so you have the indirect cost, and then you would have direct cost, and the summation of it, you will get total project duration. Okay, so you would have indirect cost, you would have direct cost, you would have total cost. Okay, so at the lowest point, okay, this will be your optimum duration. Okay, so you have your duration, you have your cost. Okay, so if you put it in a diagrammatic form, you will be able to find that your indirect cost usually is the lowest. So you will have here, and your indirect cost will increase when your duration increases. And then you have your direct cost. Okay, so that is the opposite of the duration. Okay, so when you accelerate, you would need to increase the direct cost, and when you lengthen, you do not need to increase the direct cost because you do not need that much of workers and materials on site, and the summation of both you will have as such. Okay, you will have one point where your duration will be optimal, which reflects the lowest cost. Okay, so lowest total cost that reflects the optimum duration. Okay, so your optimum project duration occurs when the most beneficial least cost situation occurs, taking into consideration both direct and indirect costs. Okay, so relationship between direct cost, indirect cost on project duration. So direct cost increases as project duration decreases. Okay, indirect cost increases as your project duration increases. Okay, and there is a minimum duration for any project where further reduction is not feasible. So you will have one point where your cost will be lowest, and other than that, you would increase. Whether you reduce the duration or whether you increase the duration, you will increase the cost. But there will be one point where it is most feasible for you to get the cheapest cost. Okay, so that will be your optimum duration. Okay, so project crashing is basically reducing the project duration by expanding additional resources. Crash time is an amount of time and activity is reduced. Okay, crash cost is cost of reducing activity due to time. Okay, and goal is where reduce project and minimum cost. You will have a better idea once we conduct this activity. Okay, so far any question on the description part of this topic? Okay, no, eh? All right, so the next part of this topic will be how do we calculate the optimum project cost? Okay, there are several steps that you need to follow. Okay, so basically these are the steps. Let me enlarge it. Okay, so these are the steps. First, you need to prepare a table of activities on the critical path showing normal activity duration and cost and minimum crash duration and cost. Okay, so before we can actually start coming up with the optimum or whatsoever, of course, you need to have this as the basis. Okay, so if you can still recall the activity, predecessor, duration is common in the previous example. Okay, so as a planner or as a project manager, you might need to derive the activities involved in your project. You need to derive the predecessor involved in your project. You need to come up with a sequence. Okay, so which activities come before which and so on. And you need to derive on the duration. Okay, so this is where you need to come up with the duration which is most feasible to be done. So, and before we move any further, how can I derive the activities? Usually from what do you derive the activities? Okay? Tak dengar sangat. How do you derive the activities? How do you come up with the activities for the project? You just did your test, kan?
WBS.
Yeah, WBS. Okay, so it is one of the test questions. So you started off coming up with the activities through breaking down your project into smaller portions. Okay, so through WBS. And WBS does not show the relationship. Okay, so your relationship is shown by you placing it based on the predecessor, successor, based on the different relationship. Okay, so once you have that, you can estimate your duration based on the resources you have in hand. Okay, so this is where I mentioned that if you plan it too fast, too optimistic, you might see that your project is not feasible to even complete. Okay, so that is why when you estimate the duration, it should be a very informed decision. It is not you place it such because you want it as such. Okay, so even though you work for construction, okay, but at the office, at the HQ, you need to know how feasible is it to complete a certain activity. So you need to look at the activity, the quantity of work that is being required to complete, the resource in hand, then you can come up with the resource that you estimated to apa the duration that you can complete within. So it is not simply place number and you push it on to the contractor. No matter what, you kena complete. Tak boleh. If it is not feasible, then it's not feasible with the resource in hand. So whatever duration you come up with, it should be a very informed decision so that it is achievable. It is could be done. Okay, so that is how you come up with the potential duration. And then you have the cost. How can we have this cost? Where do we actually estimate the cost from? How can we estimate the duration or the cost for each of the activities? Which part of a contract or construction or contract document that highlights cost?
BQ.
BQ, yeah? Okay, so you should be able to relate that to BQ. So actually when you come up with the WBS pun, you can actually relate it whatever activities that has been placed in BQ sebenarnya. So you can cross. Okay, so whenever you come up with the WBS, dia tak adalah from scratch actually. So you can actually relate it back to the big activities in BQ, the work specification in BQ, and that is where you can actually find the cost as well for each activity. Okay, right. So whole of this basically you can get it from your document, but the additional is where you have to play a role as the designer or as the planner to see how feasible is it for each of the activities to be crashed. Okay, so sometimes we place the duration as the most feasible, but are there opportunity for us to actually reduce it or basically crash the duration? Okay, so for example, activity A, okay, the normal duration with the resource we have in hand is 3 weeks. Let's say the client has requested, so you have done your planning and you have provided a duration as such. But let's say the client get back to you to say that, okay, I'm not happy with the current duration that has been planned. Is it possible for you to reduce the duration? That is where you need to come up with this crash part. Okay, so for example, activity A, you think that you can crash it to 2 weeks. Okay, so maybe with the resource you have in with the current contractor resource 3 weeks, but you think that okay, it is possible for us to add the resources. Okay, maybe you can hire one machinery from other subcontractor and so on. You can reduce the project to 2 weeks. Okay, meaning that you can have a what they call compress 1 week. You can reduce it by 1 week, but of course, when you reduce it by 1 week, you need to increase the direct cost. This might be the cost of hiring the additional equipment from outside. Okay, so your normal will be 175. You might need to increase to 235. Okay, so there are additional costs that occur. Okay, so for example, activity B as well. Okay, so you might think that, okay, you can reduce it. You can reduce it to 4 weeks. So which means you can GMAT or you can accelerate 2 weeks. Okay, and you might think that there are some activities, for example, activity H. Okay, so the normal duration is 4 weeks, the crash duration 4 weeks. You don't think is feasible. So with the resources we have, and there is no way we can add on any resources, then you remain the normal duration and the crash duration as the same. Okay, so you can basically do that, right? So these are all produced by the planner. Okay, so especially when the client mentioned that, okay, given the original, he wants the project to be accelerated. So you might need to figure out for each activities what are the potential reduction duration and how much it will lead impact on the cost, increase cost. Okay, all right. So once you've done that, okay, so prepare a table of activities. So you need to calculate the cost slope. Okay, so cost slope is basically, hold on, eh? So your cost slope, this one, so it is basically your crash cost minus your normal cost divided by your normal duration minus your crash duration. So your cost slope would show you how much increment of cost if you reduce the activity. Okay, so if you reduce the duration of the activity, so you would get how much cost increment per week, for example, if you crash the activity. So that will be cost loop. Why? Because usually we will crash the activities from the minimum cost loop. Okay, so you need to find the cost loop for each of the activity. You may start with activities which are critical, but if no, you can actually just find for all and we start with the minimum cost. Just get this first, later we'll go through the examples. Okay, so you will omit activities which cannot be compressed. Okay, so compress the activities with the least cost loop and so on. Okay, I think rather than reading this because you can't see it, let's go through the example. Okay, first thing first, what I need you to do is I need you to draw an activity or not for this diagram. Okay, so draw an activity as such. Okay, so you have the activities, you have the predecessor, and use the normal duration. So everyone, please have your paper with you. Draw the activity or not for this. So this activity, the predecessor, and normal duration. So please do that. You should be able to get a diagram like this, I suppose. So could you please do that first? Okay, have you completed on the diagram?
Yes.
Yes.
All right, so the next thing I need you to do is basically calculate the forward and backward pass for each of the activity. Okay, I make 9. Okay, so next thing basically identify the critical activities. Okay, so you will see that you have critical activity A, B, D, F, and G. Why do you think we need to identify the critical activities?
Because having longest duration.
Is the longest, but basically what we are trying to do is we are trying to crash the duration here, correct? Okay, in order for you to reduce the final duration, your activities, critical activities is the one that you can actually reduce. Okay, so in order for us to compress the duration, because at this moment, for example, your client is unhappy with 23. So 23 weeks is basically the duration that you got from normal. However, let's say the client says that is it possible for us to reduce the duration and see how much also would it impact in terms of cost. Okay, so from 23 you are trying to reduce to 22, 21, 20, 19, and see how it reflects on the cost. So for us to cut this duration, the activities which could actually reduce will be critical activities. If you, I think I've mentioned in the last class, if you cut any activities on critical, okay, or if you impact anything on critical, it will impact the project duration. If you increase critical activities duration, it will increase project duration. If you reduce, then it will reduce. So that's why once you have done it, in order for you to do the crashing, you need to identify the critical activities. Okay, so once you have identified the critical activities, check whether which of the critical activities cannot be crashed. Okay, so you have A, B, D, F, G. A can be crashed, B can be crashed, D can be crashed, F cannot be crashed. Okay, so meaning to say that you cannot reduce the normal duration anymore. Okay, so hence you can eliminate F to be calculated on the cost load. Okay, so the others can. So next thing is calculate the cost load. So for example, activity A, okay, so the direct cost is 235 minus 175 divided by 3 minus 2. Okay, so activity A, just make it small here. You only have one day for crashing. Okay. And then for activity B, 500 minus 300. So 500 minus 300 divide by 6 minus 4 apa tadi? B. 6 minus 4. Okay, so that will give you another cost load. So here you can crash the activity by 2 days. So just make a small notation here, 2. Okay, so 1 here reflects 1 day that you can crash. Okay, B can compress it 2 days. Okay, so you can cut the activity to 2 days. Okay, so 2. Activity D is basically 230 minus 150. Okay, so 230 minus 150 divided by 6 minus 5. 7 minus 6. Okay, and goes to activity G as well. 115 minus 110. So 115 minus 110 divided by 3 minus 2. Okay, so activity D, we can compress it 1 day. Activity G as well, 1 day. Okay, so what is the cost load for activity A? Here,
60.
60. Activity B,
100.
100. Activity D,
80.
80. Activity G, 15. Okay, so these are basically the cost load. Okay, meaning to say that along these critical activities, okay, in order for you to actually what do you call accelerate activity A, you need additional cost of 60. In order for you to accelerate activity B, you need additional cost of 100. Okay, so the next step is basically for us to do the compression. Okay, so let's say we conduct, can I put it somewhere? Okay, oh, maybe here. Okay, so out of here. Let's conduct the first compression. Okay, so the first compression meaning to say that we want to select activities among the critical path. We start usually with the lowest cost load. Okay, so usually we start reducing based on the lowest cost load. If it is possible to reduce the duration, you have to see. Sometimes the lowest cost load, tapi your critical activity cannot reduce the duration. Okay, so it depends. So there are circumstances as such. So let's see activity G. Okay, so this is activity G. And you can reduce it maximum by 1 day, which means you can actually compress only 1 day. So the crash duration is 2, normal duration 3, and this is the lowest cost load. So I might select the first compression, activity G, because if I cut activity G 2, so 20 plus 2, 22. So you can reduce the duration. So that is our intention, to crash the duration. So boleh. So hence I will choose this as the first compression. So your first compression will be activity G by 1 day. Okay, and it will incur a cost of 15, additional 15. Okay, so 22, and coming backwards you have 22. So if you cut here, you tak payah recalculate back because the figure will be the same. Okay, so if you cut here 20 minus 2, you still remain 20, 20 to 16. So you don't need to recalculate back and rewrite the whole thing. Okay, so this will give you a duration of 22 after your first compression. Okay, so here you cannot reuse activity G. Habislah. Okay, so you cannot reuse because your crash duration is too habis. Okay, so the next step is re-evaluate back. Do you have additional critical activities here? Because if there are additional critical activities, you need to place them here. You need to calculate the cost loop and so on. So at this moment, you can see that there are no additional critical activities. Okay, so still remain non-critical, non-critical. You still have activity A, B, D, F as critical. Okay, so hence your comparison evaluation will be based on apa yang ada kat sini. Okay, so you can start conducting your second compression. Okay, so your second compression could be based on the lowest cost from here. Okay, so if you look into this, your lowest cost will be activity A. Okay, so check if you reduce activity A's duration, will it reduce the total project cost, project duration? So if you reduce A to 2, it will reduce the total project duration, kan? Okay, so it will affect everything here. So it will definitely reduce the total project duration. Okay, so hence your second compression will be activity A, and your compression is only 1 day kat sini. Okay, so by 1 day. Okay, so if you reduce it to 2, so 0 plus 2, okay. So you need to recalculate this. So 8 plus 5, 13, 8, 15, 8. Make sure you do it on your own, yeah, because if not, later on you will see that the figure will look messed up and you tak tahu which number is which. So make sure you just follow through and calculate it on your own here. So 15, 19, 19 plus 2, you end up with 21. Okay, so you're able to cut the project to a lower duration. Okay, the additional cost that occur, 60 ringgit here, and your duration is 21. Okay, so coming backwards, 21 minus 2, 19. Okay, so 19 minus 4, we have 15. So 15 minus 5, you get 10. So here 15 minus 7, you have 8. 15 minus 5, you have 10. Okay, so choose a smaller one. 8 minus 6, you have 2. So 2 minus 2, you have 0. Okay, so the next step before we move on to the third compression, check whether there are any additional critical path. Okay, so here is still not a critical path. Here itself is still not a critical path. So we remain with whatever we have currently. So A dah tak boleh guna because you have used tab A. Okay, so you are left with activity B and activity D. Okay, so between both you have activity D 80 ringgit, okay, and activity B 100 ringgit. Okay, so a cheaper option will be activity D. Hold on, let me change this. Okay, so the cheaper option will be activity D. So see if you reduce activity D, will it change the duration? Okay, so imagine that you cut the duration here to 6. Okay, so 8 plus 6, you will get 14. Okay, so you have 14 here, you have 13 here, and you have 13. You would still change the duration because we choose 14, the bigger one here. So you will have 14 and you will change it to 20. Okay, so hence boleh. So you can use activity D as the third compression. Not too good. Oh, because to so far, any question before we it's fine. So far, any question?
Not yet.
On the water.
Okay. All
Doctor,
right. Yes.
why we can start from first activity? I mean, why do we have to choose the lowest value of cost slope
You have to
instead
start
of
with the low. Yes, you have to start with the lowest value because we want to find the most optimum, the cheapest cost dulu. If you start terus the higher value, you cannot provide the duration with the lowest cost. Nanti I will show you because we will have a table at the end. If you put it high, then it does not reflect. We want to find the most optimum duration though. That's the reason we start with the lowest and slowly we move on to the highest. Okay, so later once we place it in the table, you'll be able to see why we actually start with the lowest. Okay, all right. So let's move
Alright.
on with the third compression because I want to complete including the time. Apa tu table tu? Okay, so okay, it's to be 20 weeks. Okay, so let's move on with the third compression. So the third compression, basically the lowest will be activity D. So we have seen it just now, it could reduce the duration. If you can't reduce, you have to think of other option, either to combine two activities and so on. Tapi at this moment, we can reduce, so we will use this. So activity D, reduce to 6 kat sini. Okay, so 8 plus 6, 14. Okay, so you have 13 from here, 13 from here, 14 from here. So 14 plus 4, 18. 18 plus 2, you will end with 20. Okay, 20 minus 2, 18. 18 minus 4, 14. Okay, so coming backwards, you have 14 minus 5, you get 9. From here, 14 minus 6, you get 8. From here, 14 minus 5, you will get 9. So you have 9, 8, 9. So 8 is lower. Okay, so basically sama lah. From here, it will be the same. So it shouldn't be a problem. Okay, so the third compression, just now we have used up activity D. Okay, so only one day. Okay, so you have used up activity D kat sini by one day. Okay, and your additional cost is 80 ringgit. Okay, so that gives you a duration of 20. Alright, so because the question requested you to stop at 20, calculate the minimum direct cost of the work if the overall duration is to be 20. So just now the question by one of you guys, why we start with minimum? Because we require the minimum direct cost. If you start by having the highest and so on, then it does not reflect minimum direct cost. We want to see that is it possible that we reduce the project duration, but the additional cost to it is to be at the minimum level. Okay, so that's the idea. So hence, that's why we cut from the lowest to the highest. Okay, so let's say with 20 weeks, we want to see what is the minimum direct cost that will occur. Okay, at this moment, all right, so what we need to do is create a table. Okay, so have duration. Okay, and then direct cost. And then you have indirect cost. And you have total cost. Okay, so start from the original duration, we have 23. and then you cut down to 22, and then you cut down to 21, and you cut down to 20. Okay, so try to calculate the direct cost for each of the activities. Okay, so for 23, okay, is the normal duration. So try to calculate, this is the normal duration, okay, without any crashing or what's not. This will be the direct cost. Can you find the total sum of the normal direct cost? So that will be the direct cost for the duration of 23. Okay, so your 23 is the normal duration. So could you try sum up the entire direct cost here first? Dapat. How much is the direct cost for 23?
2025.
2025. Okay, so you should get for normal duration 2025. And then when we come to 22 ni, we add this compression. Okay, so we reduce activity G by 1 day and the additional cost is 15 ringgit. Okay, so for 22 will be 2025 plus 15. Okay, that will give you 2036. Okay, so that will give you additional cost of this. Okay, and then from 22 days duration, you cut it down to 21 days. Okay, so 21 days, activity A, additional of 30 ringgit lagi. Okay, so 2336 plus, how much? 60 tadi. Okay, 60.
Doktor,
Yes.
yang 2021 tu dari mana? Untuk duration.
2025, sorry. 2025. 2025 plus 15. So that will be 2040. Okay. And then 2040 plus with 60. That will give you 2100. Okay. And then carry forward 2100 plus with the last compression that we did for 20 weeks ni 80 ringgit. Okay, so that will give you 2180. Okay, so to answer your question, calculate the minimum direct cost of the work. Okay, if the overall duration is to be 20 weeks, this will be the minimum direct cost. Okay, so because it requires you to have the minimum, you can actually if it did not, right, okay, if we did not mention that minimum direct cost, then you can put any figure. Cuma normally if you are talking about time cost optimization, our aim is to provide we would start with the minimum cost until the maximum crash cost too. Okay, so that's why whenever you come up with this, that is the reason we have this cost slope. If we don't have, if we do not, we are not being critical about minimum direct cost or minimum addition though, then cost slope ni, then it is not necessary pun. Okay, but that is the way. Okay, so for you to come up with the most optimal duration, we start with cutting the slope of the lowest cost. Finally, we don't have choice, then the higher cost will come into picture. Okay, so at this moment, you can see that if we started crashing with activities at the beginning, so let's say we started the first compression with activity A 60, and then we crash activity B with 100. Dia akan tinggi lah cost kat sini, direct cost. So that is the thing we don't want. We want to start from the minimum. That's the idea. Okay. Alright, so next one, you have completed A, you have completed B. Okay, so let's say the indirect cost is given 200 per week. Okay, so because indirect cost, you can't calculate from here. Usually, it will be given to you because it's a constant number. Okay, so let's say it's 200 per week. what will be the total cost for the following? Total normal duration without crashing and project at 20 weeks. Okay, so hence your indirect cost here will be 200 times with 23. Okay, and then you have 200 times with 22. 200 times with 21 and 200 times with 20. Okay, so you should get 4600 ke?
Betul.
So, okay, 4200 and you should get 4000. Okay, so your total cost, total project cost will be your summation of direct cost and indirect cost. You tambah dua benda ni. Okay, so you should get 8625 kat sini. 6625. Okay, so what's the next?
6440.
Next. 6440. Next.
6300.
Okay. And the last one,
6180.
6180. Okay, so you can see that at the duration of 23 weeks, your total is 6620, 22 6440, 21 6300, and duration of 20 ialah 6180. Okay, so to answer the question, okay, what is the total cost for the duration? Normal duration, this is the normal duration. Your total cost is 6625. Okay, and at the project 20 weeks, okay, your total cost is 6180. All right, so basically that would answer the question that is being given to you. Okay, so far any question for this example?
No.
Okay, so the consequences is, okay, given that these are the duration, if I'm the client, if I require the project to be accelerated, then I would agree for the contractor to carry out the project at week 20 with a much lower cost. Okay, so if the client did not request it as such, you wouldn't know what would be the consequences if you reduce the duration. These are just some examples. There are situations where when you reduce the duration, you will also increase the cost. So it's just that this is balanced back by the indirect costs which are high. Okay, if the indirect cost is low, then your direct cost would influence this and your total cost will increase juga tu. Okay, so it's just that this is balanced given that your indirect cost is high in this situation. So it's quite difficult for us to say that, okay, if project reduce could be higher or lower. It depends on how the direct or indirect cost plays in the picture here. Okay, so with that, you will complete the optimum. I wouldn't say optimum. Why? Because kita tak complete the whole cycle. We haven't completed activity B. Kita still have activity B where we can crash. Why we stop is just because the activity requires us to stop at week 20. But actually, we can go further than week 20, I suppose. Okay, so what I need you to do, okay, kita stop at 20. But I want you to see, can you actually further your compression with the fourth and fifth compression, because your activity B can be compressed lagi. Okay, and check whether there are new critical activities that arise from here. Okay, so let's say you have the fourth compression, activity B, cut by 1 week. Okay, so you have 5. Okay, so 5, 2 plus 5, you should get 7. Okay, so you get 7 here, 7 here, 7 here. Okay, so 7 plus 5, you should get 12. 7, 6, 13. 7, 5, 12. Okay, so you have get 13 here. So it will still reduce the project duration to 19. Okay, so your homework for today, try to complete the rest of the compression. Okay, so try to complete this cycle. So is it possible for you to complete the activity B with the compression yang sedia ada? Okay, so you should be able to have fourth compression, maybe fifth. I'm not sure, you might get 6 because kita still ada activity yang non-critical. I don't know whether it will turn into critical. So try to do that. If it turns into critical, you need to calculate the cost slope balik for activity C. Okay, can you do that? We'll discuss tomorrow. Can you do that, guys?
Yes.
Yes. Okay, so good. So try to complete the cycle. At this moment, kita tak complete lagi cycle time cost optimization ni. We have just completed at the duration required. We did not complete the whole cycle sampai dah tak boleh proceed with the crashing. So try to do that on your own. Make sure you clearkan the numbers, okay? Make sure you see it properly. So left is activity B here. I will share the slide in the group. Okay, so try to do it on your own until you can you can't crash anymore. Okay, so we'll discuss this tomorrow. Okay, all right. Any question for today? Okay, so if there are no questions, we'll continue tomorrow with this example because I want to see whether we can crash anymore. So if you can add on to here, you might be able to crash 19 ke, 18 ke. So do it here and we'll check on the result tomorrow. Okay, all right. So if there are no other questions, we will end our session here and thank you for your attendance.